Stress. What about strain? Elasticity of steel. Elasticity. Measure dekat mana, Yaka? Where can we measure elasticity?
Yang dekat point garisan lurus tu.
Ni. Okay. Betul. Ini represent apa? This is elastic phase. But it represented by Young's modulus. Young modulus. So, for comparison, steel and concrete. Concrete kat sini. This is concrete. So, what can you say? This one higher or lower compared to concrete? Other than Yaka. I do not want Yaka. I want other person too. Apa? Muhammad Akil? Muhammad Akil Faik. Yes. Muhammad Akil Faik. Tinggi ke rendah? E. Still, compared to concrete from this diagram. We do not talk about higher concrete strength. We concentrate specifically in this figure, referring to this figure. The response, the response from stress strain diagram. E kat sini. Tinggi ke rendah? Dah buat lab kan? Ada tak lab buat ni? Ada tak lab ajar E? Kalau lab tak ajar E, awak komplain dekat fakulti. Awak yang rugi sebab lecturer tak ajar. Awak yang cakap lecturer tak ajar. Pada saya patut ajarlah. Dan saya tak tahulah dia ajar atau tidak. Bagi saya takkanlah tak ajar. Mesti ada ajar ni. Ini paling penting. Ini belajar di awal-awal pengajian. Ni, apa ni? E kan? Tinggi. Okey. Kalau tinggi, apakah maksudnya? Ni tinggi, so this one is rendah lah. Okey, agree Siapa yang tak agree? E lagi tinggi dia still compared to concrete. Siapa tak agree? Okey, tak ada jawab, so saya anggap semua agree. Okey, kalau semua agree, saya nak tanya. Jadi saya kena tanya. Sebab agree, saya tanya. Shushmita. 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 Adakah awak di sana? Kalau tak boleh pakai mic, boleh chat. Shushmita. Call Shushmita. Siapa kawan baik dia, call. Saya cari ke? Tak ada. Siti Aisyah? Siti Aisyah?
Ya, Doktor.
Okey, Siti Aisyah, tadi E kan? E. E ni bagi tahu apa? Kalau dia tinggi tu dia bagi tahu apa? What can E tell you? Siti Aisyah.
Dia lagi elastik.
Bukanlah. Bukan tu yang penting. Maybe like elastic portion dia sampai atas, dia lagi tinggi. Okay.
Tentang strength dia?
Bukan. Strength dekat sini. Ni strength. Saya cakap strength ialah. Ni semua strength lah sebab stress kan. Dia bagi tahu pasal P. Okay. So E can tell you about stiffness. Means that steel is much more stiffer than concrete. Kekukuhan, stiffness. Okay, much more stiffer than concrete, which is good. Much more stiffer. Okay. Okay. Sekejap ya. Okay, we go to next slide. Tapi sekejap saya kena pick up call ni sekejap. Okay, next slide. Okay, so I hope you can learn something. Sebenarnya you dah kena faham. Ini penting tau sebab kita design. Kita dah design part ni. Kalau you tak kenal lagi benda-benda yang material properties ni, macam mana ni nak guna parameter? Macam mana nak estimate the response? Yeah? Okay? Okay, it's okay. Okay, still section are roll section. But okay, actually we have a few type of steel. We have carbon steel. We have carbon steel normally is a rolls steel. Roll means that it is the steel manufactured by certain method using hot rolling of the steel billet in a rolling mill, and also we have cool form steel. Cool form steel also roll steel, dia tergelek. Okay, but for cool form, the steel roll at during the cold stage, sejuk. Hot rolling dalam keadaan panas lah. That's why you will cross into certain term like a hot roll, cool form. Hot roll normally kita selalu cakap hot roll je, hot roll steel. Cool form is cool form. We understood that cool form, the rolling process during the cold stage, or form steel, or build up section or fabricate section, means that it will not have standard size, but you build up the section based on your desired size. Sorry, saya tak sihat. Okay, based on your desired size. Sometimes you need to build up the section because of the standard size which are coming from, okay, for this class, we will refer to standard size based on Blue Book, okay? So, in the Blue Book, you can see a lot of sizes. I just take one cross section. We call it as universal beam. See how many section do we have? Banyak kan? See? Okay, the largest is 1 meter. 1 meter. 1 meter. And then the smallest is 300. Tak lagi. 127 millimeter in term of dia punya depth, in term of the depth, the height. Sorry, not depth, height here. 127. Okay. This is design method section. The actual height is 127 too. Somewhere it will not be the same for all cases. Okay, you can see from here. Okay, this is section designation. This will represent the sikit. Ambil atas. Okay, I'll take the section on the top. Okay, this one 305 means that this is the height roughly 305 millimeter. But if you look at the actual height, it's only 311. Okay, this one represent P 127. The actual 125.3. So you can refer to this diagram. This is H1. This is the, this is the B, the breadth. TW is the thickness of the web. Okay, this is, we call it as a web. This one, we call it as a flange. Okay, see, flange, this is the thickness of flange. Okay, boleh faham? That is how you use the standard standard table. Okay. Okay, that is about term. Hot roll, cool form, build up, fabricate, and build up is sama lah. Okay. Normal structure steel has tensile and compressive yield strength in the range of 250 to 400 MPa, which is 8 times more than the compressive strength of normal concrete. We talk about normal concrete, and over 100 times more in terms of tensile strength compared to normal concrete. Okay. Okay. Yield strength. Yield strength is an important characteristic in determining load carrying capacity of structural element. That's why, okay, you will notice when we calculate, when we want to determine capacity of the structure, or the term that we use is resistant. The formulation will be moment, capacity, resistant. Actually, MCRD. Moment, M stand for moment. Okay, saya tulis lah. Okay. In design, when we talk about strength, this is the formula. Moment, this one represent moment. Capacity, RD is resistance. So normally kita akan guna term ini. Also V, C, RD, V stand for shear. This is the capacity, resistance. Okay. Okay. So yield strength is important characteristic because this parameter will be included when you want to calculate the capacity of the structure element. It is important parameter or properties, I would say. Properties. The elastic modulus or Young modulus, E, measure the stiffness. See, measure the stiffness or stress per unit strain of material. E, much more important when we consider buckling. Okay, buckling. Buckling, you can relate to structure like column. Okay, of course, the load will coming from the top. Again, then it will buckle. This one, for this kind of structure element, E is very important. Okay, for beam it will not buckle, but instead we say it will deflect. It will bending, kan? It will bend. Okay. Okay, we'll not go to detail for this slide. You can have my slide and read on your own. Okay, now it is about, steel properties, okay? To design effectively, okay, of course you need to know, not something lah, tak best lah cakap something. You need to know about properties of material. Steel is the strongest, stiffest and densest of the common building material. Okay, open section. What can you understand about open section? Okay, saya cakap je lah. Open section, for example, this one. This is open section. This is universal beam. Okay, we have another open section, UC or universal column. This is the shape. See, it is open. Then we call it open section. Okay, we also have closed section. For example, circular hollow section. This is closed section. Okay. So for open section prone to torsion force. Okay, it's prone to torsion force. Then when you want to evaluate the capacity, you need to consider torsion resistant because of the shape, because of the open section shape, from the testing, normally they will have much more lower torsional stiffness compared to closed section. Okay, box section, okay, this is closed section, it will have higher flexural. So what is good about higher flexural? High flexural, of course, for element that you will use for flexural member like a beam, kan? Kalau box ni bagus dalam flexural, biarlah dia jadi contohnya. And also, box section also having higher torsional stiffness. In case for bracing system, okay, particularly compression brace, a circular hollow section is most efficient structurally. And the section also offer greater resistance to corrosion and also lagi cantik, much aesthetically pleasing than open section. That's why if you look at pressing member, you will not find like an angle section. Normally we will use closed section. Hollow. Closed section is hollow section. Okay. Okay, ada nak tanya? Is there any question? Okay. Height resistant to weight ratio that will lead to lighter structure weight, possibility for bridge, larger span, of course. It is common sense. Bridge, of course, you need larger span. Otherwise, you need to prepare pier, many piers. Okay, pier. Okay, for bridge, bridge. Of course, you need bridge. Why you need bridge? Of course, you want to cross certain obstacle, kan? This is not like a river lah, river. Okay, you need larger span. Yeah. If this member heavy, it might deflate due to its own safe weight. That's why you need much more lighter structure, but the one that can go for larger span. Lighter but can go larger span. Okay, so otherwise you need support. Support we call it as a pier. Pier kat sini, pier kat sini. Okay, that's the ni lah, common sense lah, kan? Okay, if you can have lighter weight, means that lower load to much more lower load that will support by the foundation. So you do not need larger foundation there. Okay, and still is homogeneous material. Why it is homogeneous? Because it was manufactured based on, of course, in control condition at factory. So it is homogeneous industrially produced material with predefined and guaranteed properties. Okay, other properties is ductility. So what can ductility do? Ductility, it's ductile. Ductile ni mulur. Macam you pegang plastik kan, getah, band, the rubber band. You can stretch the rubber band. Kan, stretch jauh. Baru diputus until it break. Okay, That is ductility. So steel actually ductile. The ductility, the opposite of ductility is brittle. Kan? Brittle, if the material is the characteristic of material is brittle, it will have sudden failure. But for that, for material that having good ductility, before it fail, it will like sort of warning the user before it fail. That's the good thing about having material, having ductile material. Okay, the ductility actually allowed redistribution of force, especially in the case of accidental load and unexpected situation. That's why steel is much more better than concrete, because it is higher ductility. Okay, high connectivity that allow speedy erection. See, kalau lebih cepat pembinaan itu siap, apa maksudnya? Lebih cepat user guna, lebih cepat duit dapat oleh pembekal lah dalam kes ini bukan kontraktor, apa panggil? Lupa pula. Okay. Kalau bangunan tu komersial, then orang boleh berniaga cepat. Itu kelebihan. Okay, durability. Durable, tahan lasak. Durability provides sufficient maintenance, is guaranteed. Tahan lasak. You want durable car, right? Because we do not want to visit workshop frequently. Okay? Kita nak semua. I need something that durable. Okay? So ductility, okay, this is properties also. Durability, ductility, this is the characteristic of ataupun properties of certain material. Okay, ini tak apa nampak. Okay, ductility is the property of material which it can withstand extensive deformation. Ubah bentuk yang extensive without failure under high tensile stress. That one you said as a ductile. Structures still are ductile at normal temperature under normal condition. Normal temperature, okay? If you have an event of very big fire, do not assume that the steel will sustain more loads, okay? That's the weakness of the steel material, okay? But of course, when you choose to use steel material, you have to come up with the fire protection. Okay, this property has two important implications for design. First, okay, for ductile material, it will have high local stresses. For ductile material, it will have benefit, especially when it comes to having high local stresses. High local stresses will occur or will experience by the structure when you have concentrate load or stress riser. For instance, stress riser is due to you need to having holes because you need to use bolt and nut for connection. Hole that you prepare will create high local stresses. Okay, but since the steel structure is a ductile material, it will not give you a major problem as they are with high strength steel. Using usually a major material as they are with high strength steel because ductile steel can yield locally and relieve these high stresses. Okay, sebab connection selalu kita nak guna bolt and nut, kita kenalah prepare hole. Bila you ada hole, akan ada stress concentration dekat hole tu. Okay? Tapi don't worry, if you having ductile material, the characteristic tu dia boleh release this high stress. But of course, there's a precaution for you to design, okay, or to provide holes. There will be condition that you need to obey. Mesti ada syarat. Okay, ini tadi dah. Okay, ini ada salah sikit. Repeat. Okay. Second, ductile material have high toughness, means that they can absorb energy by plastic deformation so as not to fail in sudden catastrophic manner. For example, during a quake. Okay, this is important. It is important to ensure that ductile behavior is maintained. Okay, there's a lot of other explanation regarding ductile. I'll leave it to you, okay? I do not want to go into much detail until microscopic. I do not want, I'm not metallurgy person, okay? But of course, you can read to, as for your knowledge, Okay, this is explaining about the arrangement of atom in the structure, steel structure, the microscopic, because actually the process of manufacturing will affect this one. Okay, that's why between the hot roll and cool form, there's a different properties, okay? Because the grain size was also affected by the type of manufacturing. Okay, see, this is an example. Cool cooling of steel cause grain growth and reduction in steel toughness, increase the possibility of brittle fracture. Nampak tak? Okay, residual stress means that you put stresses in. Okay, you put stresses in the structure. Okay, it will result apart from manufacturing process. Residual stresses also can coming from like welding. You do welding, actually you put stresses. So residual stress, okay, reduce the fracture strength, while surface temperature influenced whether the steel will fail in brittle or ductile manner. Okay, so almost 1 hour. I need all of you to answer my one question. Okay, one. Okay, first. Okay, please answer this one. Dalam author, within 5 minutes boleh? Okay, tolong answer first question. Height strength per unit weight of a structure will result in a bigger size. Agree or not? Sekejap, saya masuk balik takutlah dia idle tadi dia akan keluarkan saya. Mana? Kan nampak ni. Dia tak boleh receive. Okay, saya dah allow. Please access your author. Okay. Yang lain-lain? 5 minutes Okay. Oh, 3 orang answer. Siapa yang nak bertanya, boleh bertanya. Ada pertanyaan? Is there any question from you? Okay, saya tunggu sampai 5
Doktor tak buka mic.
Sorry. Okay. So saya dah tamatkan pool. Okay. Okay, we continue to our lecture. Okay. So still section So actually we have various shape and size of course of steel section. We have typically we will use UB, UC, channel, angle. That is the most section shape that being used widely or practiced in construction industry. Circular hollow section and rectangular hollow section. Yang lain is tak berapa. Okay. Structure still not common. Okay. The common one is just this one. Okay, here you can see UC and UB looks like similar, but if you look at closely, you can find that UC more like H shape. That's why sometimes UC we call it as H section, while for UB, this one UB, it looks like I, right? I. So that's why we call it as I section. H section, I section. This is the beam, universal beam. This is universal column. Ni salah info ni. Okay. Okay. Channel. Okay. Angle, sometimes we combine it. So it will be double angle. T section, not normally used. Okay. So I just want to stress that here that in our syllabus, the selection of size will be according to Blue Book. And also, we will not learn how to design build-up section or fabricate section or cool form section. Instead, we will concentrate on hot roll section using the size from standard size in Blue Book. Okay? Di luar, kita tak concentrate. But it is possible for you to learn on your own other type of design. But after you have learned hot roll using this standard size, because to me it is like a 90% similar, just different properties, and maybe there's certain important condition, maybe because of the limitation of the structural property, because it is different material kan, different process, different material properties. Of course, ada certain limitation that you need to consider. Okay, steel section. Macam mana kita nak panggil steel section? Okay, we know that we have various steel section shape. Shape varies. Size also varies. Okay, for universal beam, okay, this is universal beam. For example, for universal beam, not only beam, UB, UC, channel, we identified them. How we write the size is by depth times breadth times mass, and then you can put shape. Okay, this one lah. Height. This is how you name it. You write the section. 305 times 107, 27 times 48 time. Don't put time. Just put UB, EUC. This one is 48. This one is kg per meter. Kg per meter. You can put 48 kg per meter UC, UB. Okay, that's how you write it. Okay. Okay, for element that having constant thickness, for example, angle having constant thickness, you do not have to memorize. Instead, you have to understand. That's all. how do we know whether it having constant thickness or not? Okay, boleh tengok. You can refer to this blue book. Okay, for UB for UB, different thickness, right? See, thickness, different thickness. It's not constant. But for angle having constant thickness. Angle. Where is angle? This is called form, Angle. Okay. Angle, we have unequal angle, equal angle. It is about the different measurement of the leg. This one. Okay. Angle. See? 200. Tak boleh ni. Unequal. Mana? When we set constant, doesn't mean all constant, but in a large group, it is constant, Okay, tak apalah, tak jumpa. Okay, so how do we write angle? Okay, we put it as a breadth times depth times thickness times shape. Shape is L shape. Okay. Okay, so this is the example. Just want to show you what is height. This is height. This is the B here. Okay. Okay. Okay, web and flange. Okay, this is web. Web. Flange. Web perpendicular to flange. Okay, that is web. Okay. Do not remember that. Do not memorize that. Okay, just understood web. Web, it is being connected at both ends. Okay. See, web connected here and here. While for flange, one end is free, one end is connected. Okay. Kita tunjuk macam ni. Ni, this one. Measure here. Free, connected. Ini connected. That is web. This one is flange. Okay, this is angle. Of course, angle also have various thickness. Okay. Maybe I do not have to agree with that note. Maybe we do not have to say that where thickness is constant. No. Don't think that. Thickness is the thickness. We still have various thickness. Okay, for example, okay. This an angle. This is how you write the size. Okay. What else? Build up section. Like I said, build up section means let's say you need bigger size, but the bigger size in the standard section, I mean from the blue book, okay, from the blue book, okay, could not meet your design requirement, okay. The largest section could not meet your design requirement. Let's say the largest size, okay, 1,000 something, right? Okay, only capable to support, let's say, 1,000 kilonewton. But in your design, you need something, you need element that able to support 1,500. So the other option is you come out with build up section, and then you design it. Okay. Okay. See, that is build up section. The fabricated section. Normally you can see this for the applied on the bridges. Okay. Okay, hot roll. See, this is hot roll. Nampak? Being rolled into desired shape at hot stage. While for the cool form, you can see like a coil here, steel coil, steel sheet, steel sheet, then it will roll. But during the cold stage, that's why it is cool. We call it as a cool form. This one is as a hot roll. Okay, mechanical properties kita dah sentuh sikit. Okay. Okay, mechanical properties. See, all manufactured material properties vary. Different. Pelbagai. Vary because of the molecule structure of the material is not uniform, and because of inconsistency in the manufacturing process. The variation that occur in the manufacturing process depends on the degree of control. Okay, variation in material properties must be recognized and incorporated into the design process. See, at the front pages of your Eurocode, Eurocode at clause 2, there's a information regarding the testing of steelwork, because we try to control, and if your material not fulfill certain things in certain clause in the Eurocode, means that you cannot use that Eurocode to design your structure. Okay, major advantage. Okay, this one you already know. Okay, this one about, okay, material properties is important. Okay, when we talk about strength, okay, the important thing is about its strength and also its Young modulus. Young modulus related to stiffness. Okay. Okay. This one I think you also learned during the I think you are being introduced in concrete structure, because certain value, we will use constant value. How they come with such constant value that can be applied to all design? Of course, it will based on analysis. It will based on statistical value. Okay. They are not randomly pick value. Okay. See, this is how they do it. They just took 1% of the bigger pool of result, and then they go to the the lowest part. That's how the researcher can ensure the designer to use certain value. But of course with certain analysis. Okay, I will not go into detail on that too. Okay, Fy is the yield strength. Actually, this is the yield strength. I put it point because this note will lead you to stress strain diagram. And it will lead you to where is the point of Fy. Okay, Fy, what is Fy? Fy is the yield point. The yield point is the stress which the proportionally between stress and strain changes. Some of the steel material has both upper and lower yield point. Ada dua. certain thing, a certain material still. But for design purpose, you need to consider minimum. Of course, you need to consider lower yield point. Okay, apa maksudnya higher and lower yield point? See, you can see from here. This is the example. See, this is the elastic. One, it reached at point A. This is called as limit for proportionality. Perkadaran tu dah habis. After that point, there's no proportion to tak sama. It will not be the same between the stress and strain. See, that's why you can see the curve, a bit of small curve here. Okay, then at B point, this start the yield point, or we call it as rolling point or upper yield point, because it is at upper part kan. That's why upper. Another yield point is here at C. This is lower yield point. But in design, please use lower yield point. Okay. Yield strength is important parameter. For how, okay. And then, okay, this stress response has obvious point of yield strength or yield point. Nampak obvious kan? Ada obvious. But there's a certain result, I mean stress strain curve, that's not showing obvious yield point. Okay, the characteristic of the diagram is like it's much more rounded curve, like this one. Nampak? Rounded curve. So you cannot determine where is the yield point. Okay. This also you not have to learn. You should already learn during the lab or material construction material. If you do not being taught about this, please do something. Let faculty know, so we know that it is not in syllabus or it being skipped or not. Yeah, but this one is important. Yeah, for like I said, before you want to design any structure, you need to know its behavior. You need to know their properties. How can you design something without knowing the background of that material? Okay, so again, yield strength is important. For this kind of curve, I call it as it is rounded curve. You do not have an obvious point of the yield strength. So what you need to do, you need to do 0.2% offset, where the line will be parallel to the elastic part, and then you offset, you move to 0.2% of strain, and then the pertembungan. This point will be your Fy. Okay, how can you know about the properties of the material? Okay, you have to do tests. This is called as tensile test or tensile test. Apa lagi you pakai? Oh, coupon test. But this one is not coupon. This one is reinforcement. Sometimes for steel structure, not sometimes. For steel structure, not reinforcement, you need to prepare coupon. Bone, it's like a bone shape. Then you test it. And you pull, you put tensile force there. Then you come out with the stress strain curve. Okay, based on its stress strain curve, other than Fy, you can also determine the Young modulus. This is the slope between stress, strain. And then you can know the ultimate strength, which is Fu. Fu is the ultimate strength. And then lastly, it will fail at fracture point. Okay, that's how you can get properties, okay, certain parameters. Okay, but based on Eurocode, okay, if the material fulfill BS EN 1990, then you can use this code for your design phase. Then you can use certain constant parameter like E. Okay, E we will use this value. This one is shear modulus. Okay, you can also use the actual value of E based on your testing. Okay, boleh. Okay. Okay, this one. E, where can you get E? That is from relationship between stress strain curve. The material properties, this is a material properties and therefore value from a set of sample vary. Macam tadi, the curve tu. However, the variation for steel is small, that's why you can assume as 210 gigapascal. Okay, this is just another typical stress strain diagram. Okay, you know the elastic part, where this plastic part. This one is strain hardening. This one is necking and also failure. And then this is the idealized stress strain curve. Yeah, kita idealize because of the purpose to ease the design part. Okay. Okay. I have mentioned to you, steel also have various steel grade. This we can only show two of them, which is S235 and S355. This is the lower strength. This is medium lah. I would say medium. We have 400 something also. Okay, as you can see, of course, it will have this material will have different Fy. Betul tak? Kan lain kan Fy. This is stress strain diagram. Okay, one thing. Yang tadi, okay, kita cakap pasal stress. What about strain? We talk about stress. We not concentrate about strain. What strain can tell you? What is the value of strain that can tell you? What can this diagram tell you? See, you're having this one, the failure at strain maybe 27. This one more than 30. What can this characteristic telling you? What can you understand? Siapa lagi nak tanya? Syed Muhammad Osman? Syed Muhammad Osman? Syed, I've not seen you before in the list. Are you just Syed? Oh, not Syed.
Yes,
Syed. Okay, Syed.
Yeah.
Okay, let's answer. Please answer. What strain can tell you? This one. See, as you can see, this grid, fail the fracture. Maybe I estimate at 26 or 27. While for the lower grade, it can go up to more higher strain compared to this one. So what can you understand about strain here? Can you answer? Said, can you answer? Susmita. 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 Tan? Tan? Ada pun Tan. Tan, macam mana Tan? What can you understood from the strain? Said. Said, you do not want to try? Higher stiffness? No, stiffness about the E. Said. Said dengan Shusmita. Where is Shusmita? Are you not in front of computer, Shusmita? You are not in front of computer, right? Okay. Just go back to the fundamental. Apa yang susahnya? E. What is E? E is strain. How can you calculate E? E is, let's say, length. Delta L over L naught. What this mean? Means that it can stretch more compared to this one. Mean it being more ductile compared to this one because it can stretch. What is the difficulty here? What part that you cannot understood? Just relate to the formula. Means that higher strength is much more brittle compared to lower. Even though it can having high strength, the FU is higher compared to this one, but still the ductility is lower compared to the other one. Okay? Can you relate that? Can you relate that? Tan, can you relate that? Said, can you relate that? Said, I want to hear your voice. Tan, I want to hear your voice. Sumita, I want to hear your voice. Susmita. Chat, tak apa chat. Chat, boleh. Susmita, there's no response from you. Tadi pun I dah panggil, ni dia tak panggil. I kick I remove. Okay. So based on Eurocode, I see there's a different grade. We have 235, 275, 355, 450. Okay. This is material resistant. This is this section again. UB, UC, we have hollow section. And then what else? Okay, UB normally we use for fracture. Remember why? Because it is more efficient in resisting bending moment about major axis. For UC or H section, the capability will be more to resist axial load with hard radius of gyration about minor axis to prevent buckling. Angle normally used for purlin. Hollow normally used for ties and bracing. Okay. This is beam, okay, column, and then Eurocode. Okay, I do not want to explain about Eurocode anymore. You've been into, you have enrolled structural design. I think you should be familiar with Eurocode by now. It's just that for certain thing in Eurocode 3, which is you will be taught in steel class, okay, so you will use Eurocode 3 in my class. So there's a certain thing that I will highlight to you, okay, like this one, yeah. Okay, the design should be process adequate ductility. How to ensure? Just make sure this one, okay, because we want to avoid brittle fracture. Okay. Okay, about limit state design, you also have been introduced limit state design, serviceability, limit state. Okay, what is serviceability limit state? What is example for serviceability limit state? Okay, about EC also, I do not want to chat about to tell you about load. You dah belajar, you supposed to belajar. Okay, okay. Next. So one more pool. You've been given. Okay, buka auto sekarang. Sekarang 3:34 saya bagi awak. Yay. 3 minit. Okay, ambil pool ni. Siapa yang tak jawab tadi, saya akan consider Senyap je tak ada, memang tak ada lah kat depan tu. Okay, habis Sampai 3:37 je kan? Okay. Okay, ramai jawab betul lah. Ramai yang jawab betul. Okay, saya stopkan sekali. Okay. Dah Kerapkan. Okay. Okay. Next, okay. It's about section classification. Before we do the design, before we do the design of the structure, we need to classify the steel section first. Okay, this is extremely important, but only for structure that being subjected to element of compression. I said element of compression. I don't say purely compression, because buckling also have certain element of compression. Yeah. Okay. So a section or element of a member in compression due to axial load may fail by local buckling. Local buckling can avoid it by limiting width to thickness ratio, by limit the B over TF or D over TW. But in Eurocode now, we will use C, not B or D. We will use a measurement from C. I will show you where is the C. Okay. Okay. Here, according to Eurocode, sorry. Okay, based on the not Eurocode, based on the blue book. Based on the blue book, this one. Okay, based on the blue book, we will consider C. C, okay, see this one for local buckling. C over T ratio and C over this one for flange, this one for what? Okay, that is how we want to limit the local buckling in the structure. Okay, because local buckling is sort of a failure to that structure element. Okay, yeah, so to avoid, you need to limit the C over T for flange and also for the web. In fact, for each element, if you have I section, okay, for instance, you have I section. So how I section look like? Okay, this is how I section look like. So how many element? One element, two element, three element. You have one web, this is web, and two flanges. So you need to limit the C over T for 1. C over T for element number 2. Also C over T for element number 3. But since we are using I section, in I section, it has constant measurement for both top and bottom flanges. So you save a few minutes lah. Just conduct one assessment for flange. Okay, that's all. But actually for all elements, see, for each element. Okay, then you need to use limiting value from table 5.2 in the Eurocode. Where is the Eurocode? Eurocode, this one. Okay, table 5.2. Okay, we have actually 3 tables. Sheet 1 of 3, sheet 2 of 3, sheet 3 of 3. That's 3 table. Okay, so you need to limit. Okay, this is the limit. Sorry, this is the limit. Limit. This one is actual. Okay, how to use? Okay, how to use this table? This is the actual. You need to compare with the limiting value. This one is part that's being subject to bending. This one for element that being subjected to compression. So you need to distinguish them. Okay, that is the limit. So normally I will teach. I'm using jargon term by saying, okay, C over T actual versus C over T limit. I would use this kind of wording. Okay. Okay. I think that's all. Okay, we will go into, okay. There's 4 classes, we have class 1, class 2, class 3, and class 4. With the smaller class, which is class 1 being the superior, class 4 being the weaker class. Okay, class 1 is the superior and class 4 is the weaker section. Yeah, means that at the weaker section, local buckling is prone to occur. Yeah. So in order to avoid that, we in the design part we will limit certain thing before the attainment of stress that will create the local buckling. Okay, before that, what is local buckling? How local buckling looks like? Sorry, I do not put pictures, so it's okay. Online, we can always Google what is local buckling look like. How is the local buckling looks like? See, it's kind of wave lah. Macam ada wave. Okay, bengkok-bengkok. This one. It's occur locally. Occur locally. This one also a buckle, but it is overall buckle. See, overall buckle. This one, local buckling. We want to avoid that thing from happen. It doesn't mean that we have to avoid certain sizes because using these sizes there will be local buckling. No, instead you need to consider the limitation of that particular sizes, that particular structure with that sizes. Kita design lah according dia punya capability. Tak adalah kita cakap, tak payah guna, tak payah design, tak payah guna size ni. Tak ada. Bukan macam tu. Okay. So, ini. Okay. So, the classes based on what? It's based on the slenderness. That's why width to thickness ratio. It also based on the compressive stress. It also based on performance requirement for resistance of bending moment. Only these two yang kita akan concentrate. Okay, so this is class 1, class 2, class 3, class 4. Please read. Okay. Just to make sure that you know. Okay, this is the table. I do not want to explain about the layout. I think you should know by now. Also, I assume that you know about load combination because you already sit for structural design. I can skip kan? Betul? Saya boleh skip I can skip that part. So when you answer any test question or final question, please make sure that you already master this one and you don't have problem with this one. Okay? Boleh? Awak kata awak dah belajar kan? You said that you already enrolled for the structural design, right? So I don't think you have problem. Okay, last poll. Okay, remember, I will consider this as your attendance. I'm giving you like 3 minutes. Okay, for what is it? 50. 350. Okay. Okay. Please do it. Okay, saya round Ali, is there any question? Aiman, Ali?
Yes, doctor.
Do you have any question regarding the lecture today? Can you understand? Aiman, ada problem tak lecture? Ada apa-apa nak tanya?
So far tak ada lagi.
Boleh faham Ali, boleh faham? Alif, saya nak dengar suruh.
Yes, sir.
Okey tak?
So
Siapa
far
yang
okay,
ada
doctor.
dekat sini buat PSM? Siapa yang ada kat sini? Boleh datang jumpa untuk belajar dengan saya. Chin?
Yes, doktor.
Ada apa-apa?
Tak ada.
Faham?
Faham.
Okay. Chong Min Kwan?
Yes, doctor.
Okay, good. You there? It's okay. I just want to ensure that you there. Kong Hui Jun? Connie? Okay.
Yes, doktor.
Ada apa-apa?
Setakat ni dah ada.
Tak ada. Izani? Ada? Tak ada, nanti saya tanya. Boleh? FY tu apa? Apa? Semua stress strain graph. Semua tu stress strain. Apa itu FY? Alah. Li? Salah. Li Yi Chan?
Yes, doctor.
Okay? Are you okay?
Okay.
Okay. Liana?
Ada doktor ada.
Okay. MM22. Siapa ni? Afiq.
Okay, doktor.
Okay ya. Okay, kalau tak ada apa-apa, kita boleh tamatkan kelas. Dismiss. I'll see you tomorrow. Please, again, hari ni saya tak nak kick orang. Tapi saya nak awak respon. Saya tak nak ajar seorang. Okay, dah 3 tahun saya ajar online. Saya tak nak lagi macam ni. Online, pergi face to face, SEM lepas. Macam ni result, okay ke? Susah kan? Tak best tau. Jadi saya nak paksa semua orang memang ada. Memang biarkan korang korangnya. Tak apa. Saya nak pastikan you ada kat depan tu je. Saya nak pastikan you dapat apa yang saya kata. Okay, thank you semua. Jumpa besok. I'll see you guys tomorrow. Okay?
Thank you doktor.
Thank
you,
doktor. Terima kasih doktor. Selamat buka.
Thank you doktor.
Thank you, doktor.
Thanks.